All right, hello everybody. Thank you all for coming. My name is Parecki. Who's excited to geek out about home automation for the next 40 minutes? Yeah, okay, I thought so. I am curious to hear if anybody here has bought any home automation devices in the last, I don't know, like 5 years or so, especially any of, say, these ones. Raise your hands if you've bought anything new in the last, 5 years or so. Yeah, a bunch, okay. I'm calling out these ones specifically because there is a problem with a lot of the devices that I'm seeing sold right now. And that is that they essentially are, cloud connected and they require the internet to work. So the way most of these work is that you have the device that wants to go and turn on like a motion sensor and it wants to go turn on your light. It'll actually go out to the internet, go talk to the servers of the company that runs that product, and then go back down and tell your light to turn on, which is a little bit of a roundabout way to do things because the light and the motion sensor are already in the same physical location. And this, of course, causes a whole bunch of problems, right? So we see this over and over again. And I've got a few snapshots from like Twitter and things, right? So, can't turn the lights off because the servers are down. Or even if your home internet goes down, it's the same problem. Or there was this one, which was a pet feeder, where there was a server outage, and all of a sudden the pet feeders are not working, which is just terrible because that was like you had one job. It's just the timer. It's not even motion controlled. There's NetAtmos servers went down a while ago, and same thing. Now you can't control your thermostat because their servers are down, and it's not even like anything that's in your control. There was one from Google recently where now you can't change the locks on your doors or turn on the AC, which is there's so many reasons that like requiring an internet connection for this stuff is just not acceptable. This was perfect timing because in fact yesterday this line stopped working because they discontinued their servers and they just decided to shut everything down. November 6th, yesterday. So yeah, hopefully you didn't buy one of those. If you did, you might get a partial refund or something. Good luck actually, following through with that. There's just so many examples of these. I'm gonna stop giving you these examples. If you are interested in sort of watching this, trash fire burn, this is a fantastic Twitter account to follow if you're not already familiar with it. And it's just gold. So what we actually want to do instead is connected home stuff is fun, right? Internet of Things or network of things is fun, but you shouldn't have to rely on an internet connection when your devices are just really in the same house. So what we're looking for is some way to have devices in your house talk to something else in your house to control them, right? So that we can keep everything, keep the smarts at home, keep it all inside, and leave the cloud out of it. So if this is such a bad situation, like how did we get here, right? I don't actually think that these companies are like trying to be bad. I don't think they're trying to do this on purpose. I don't even think that every company building this stuff is trying to sell your data that they get from running this thing, right? I think it's actually a lot more subtle of a problem that it took to get here, which is that it turns out it's user experience, right? A company makes a product, they want it to work well, they want to sell it so people will then appreciate it and buy it, and they want it to work when you buy it and bring it home. And it is, in fact, a lot harder to make smart home devices that work well locally and are also easy to set up. Because that's often the real challenge here is that go either, figure out what IP address this device got when it popped onto your network, or figure out how to configure port forwarding through your router to allow your mobile phone to connect to it. None of that is fun. Nobody wants to do that. There's various ways around it. There's some good solutions, not very many. Bluetooth has helped a little bit, I guess, but it's just a lot easier to ship a product where the setup can happen through the internet and where also the control happens through the internet. Especially once you're talking about mobile apps, because as soon as you want your phone to talk to something at your house, especially if you're away from your house, now you do need to get through that router somehow, which is either going to be port forwarding or other magic things. We're running a tunneling service that the company runs, which is one way to solve it. So I think that's the reason we got here, is because it's easier to provide a better out-of-the-box experience, especially on the phone. But I think this is also where some of this kind of the assumptions weren't right to begin with of using a phone, because oftentimes, you'll see these ads for products where it's like, control this from your phone. And once you actually try that and get it set up, it turns out that using your phone for everything in your house is not actually a very good experience. Demonstrated very well with this quote. It's amazing how much you miss a simple light switch when you have to pull out your phone, fumble through a poorly designed app, and then wait a half a second for the light to turn on. It turns out that light switches are actually a pretty good idea. It's on the wall, it's right next to the light it's controlling, and then you can just tap it and it turns on instantly. Great. And it starts getting a little bit ridiculous too once you have voice control in it, or when you have guests at the house. This was, this Airbnb binder instructions is full of voice commands to explain how to use the lights, including don't turn off the physical switches because that breaks the system. And this is okay, I see what you're doing here, but this is you're not actually providing a good experience to your guests by having this voice command thing in here, right? And that's kind of, if you need a manual to explain how to use your house, I think something's gone wrong there. And that's kind of home automation's fun, but it should help you. It should not get in the way of what you're just trying to live in your house, right? And I think a lot of this has happened because it's flashy to show, oh yeah, you have this app on your phone, control the color of your lights. That's all cool, but it's not actually a good way to interact with a house. So what I'm interested in exploring is how can you actually design a home automation system and design this stuff both that runs locally so that it doesn't require an internet connection and also isn't actually making you do more work to control the things in your house. And I think one of the best ways to do that is to have more inputs into the system, adding context. So we'll go through some examples. You might have a simple rule that says, okay, turn on the lights when someone gets home. That sounds great, right? So maybe you have a door sensor, you open the door, and then it says, great, lights come on. Well, this turns out this fails in a couple of really bad ways. So you get home after other people are already asleep, and now all of a sudden the lights come up. That's not good. Or depending on how you're tracking how you're home, sometimes it's done through a phone app that does either Bluetooth or GPS or through the Wi-Fi. And if there's a glitch in that and the GPS thinks you've left and then come back in the middle of the night because your phone's Wi-Fi disconnected and it got confused, then again all the lights come up in the middle of the night. So what you actually wanted this rule to be was not just a simple when you get home turn on the lights. It's actually turn on the lights when someone gets home, but only if nobody's in the bed. Because if someone's in the bed, it's not going to be a good experience to have all the lights come up. So we need to find some way to add that input into the system. You might also have a rule that says, open the shades at sunrise. And that's a pretty reasonable one, but it is wasteful if nobody's at the house. You don't need to because no one's there to enjoy the light coming in the window. So you actually want to open the shades at sunrise, but only if somebody's at home. And then you, again, want to close them, but not just at some arbitrary time of day, because it turns out that during, as the seasons change, the time that the sun starts shining in the window changes. So you actually want to close the shades right before the sun would start shining into the window, but not before and not after. And that time of day varies depending on where you are and where the windows are and what time of the year it is. So we need some way to add this input into the system. You might also have a rule that says turn on the air conditioner when it's over 22 inside, and that's that's how traditional thermostats work. But we're building something that's a little smarter than that. What you actually wanted to do was, this is a problem because as soon as it's already that hot, it takes more energy to cool back down to the desired temperature. You actually wanted to anticipate it getting warm and start the AC before it got too warm so that you can save energy. So you actually want to look at the forecast and say, if it's going to be warm outside in the next hour, start the AC now so that you can get ahead of that cooling, right? So, okay, these are some pretty simple ones. Let's say that we do, in fact, now have a sensor that can tell when someone's in the bed. Now you might start adding more rules. Let's say, turn on the lights when someone gets out of bed. Well, that's, again, going to fail in a bunch of probably predictable ways by now you're thinking about these. if there's more than one of you at the house, one person gets up first, now everything's turned on, too soon. Or you get out of bed at 4 a.m. to go get some water or something, and now it's like too bright and you can't see anymore. So you actually want to, again, add more inputs into this. You might actually want to do something more like turn the lights on, but only if everybody who's currently at home gets out of the bed, which means you need to be aware of how many people are there, how many people are at home, and then again, like if only one person gets out of the bed and it's still dark out, then maybe just bring the lights up a little bit, but not full white. And then the opposite of this, of course, turn off the lights when someone gets into bed. That sounds great at first until you realize that if someone takes a nap in the middle of the day, then the lights all turn off, or if one person goes to bed first, then again, everything just gets black. So you actually want the rule to be more like, turn off the lights, but only if everybody who's at home gets into bed, or just turn the bedroom lights off if one person gets into bed. So again, we have to have, find ways to add these inputs into the system. So let's say you have all these fun lights that can do fancy colors, and you design a TV mode where you might have like dim red lights in some parts so that you can kind of see your way around, but it's not overpowering the TV. And then you want to set the lights to TV mode when the TV is turned on. And I hooked this one up actually a while ago, and it's great in most of the cases until you realize the edge cases, which are, well, someone turns on the TV and to have something playing while they're cooking dinner. And now all of a sudden you can't see what you're cooking. Or if your TV is on, but then you pause to go get a drink, it's now you can't see very well because it's too dark inside. So you actually need, again, more context for this. You wanted to set TV mode on, but only if actually someone's sitting on the couch. That way when they're cooking, it doesn't trigger that rule, right? And then maybe it's not just when the TV's on or off, but it's actually when something's playing on the TV. So that if the TV is paused, then you want to raise the lights a little bit so that you can see your way around the kitchen. Or maybe that's when someone gets off the couch. If the TV is on, then the lights come up a little bit. So hopefully this is giving you some ideas of all these different inputs that we need into the system. And there's not necessarily products off the shelf for all of these, right? And certainly not in ways that can coordinate all this together in an easy to manage way. So let's start talking about actually building this. And I'm going to share my experiences in doing this. I've been tinkering with this stuff for a long time, but I kind of took a break after the X10 days, and then I started using like smart things at one point, and I realized that it was complete crap because it was all internet connected and slow, and kind of just got disheartened after a while. So I've recently got back into it and tried and started actually building this out, and with the goal of having everything being local at home, running locally. So there's a bunch of different ways you can approach this problem. I'm not necessarily saying this is the best way to approach it, but this is what I've done and what has been working pretty well for me so far. So at the core of the system, the sort of controller brain of everything is Home Assistant. This is an open source project. They make it very easy to install on like a Raspberry Pi. They have some distributions ready. You can just install onto an SD card and pop it in. You can also install it on just any Linux system from scratch if you're used to that kind of thing. It's a very good piece of software. It takes a while to get your head around it. It's a very different way of thinking about things, and I actually had tried to pick it up like a year or two ago, and it didn't map with the way I was thinking about things. And finally, I just like took the plunge and decided, okay, I'm going to figure this out. Read through the documentation. There is good documentation, thankfully, but it is a lot of new terminology to learn and things like that. So the way I like to think of Home Assistant is this is the it's like the thing that talks to all the devices, and it's like the hub. So you can connect devices into it. They have a bunch of off-the-shelf integrations for various products, and then you can also like push custom data into it. And then you have all these inputs and you have all these outputs. So you can have sensors. You can have it be aware of the weather. You can build custom sensors, and then you can have it control things like switches or light bulbs or your motorized blinds. So they have a bunch of off-the-shelf integrations, which is actually a pretty impressive list. And again, because it's open source and there's a pretty good community around it, there's a lot of stuff in here. So you can just search for like products that you've bought and then see if it's already got an off-the-shelf integration. It's also got like custom integrations so that you can push data into it over HTTP or MQTT and make these yourself. So the thing that confused me most about this was that Home Assistant also has this whole concept of automations where you can start to define rules. And the syntax for them is basically you write a YAML file that describes the rule you want to make. And this is where it started going wrong for me because it's pretty easy to do simple rules. It's nice that it's not code. I like that. I don't want to write code for this. And like you can kind of see this as a pretty simple rule, which is like, trigger on this sensor when there's motion going from off to on, then run this action of setting this light to this color. And this is, I think, reasonably readable. The problem is once you start wanting to stack conditions or make more complicated things, it gets really unwieldy to deal with this. So I found that like as soon as I started going beyond this simple input to this simple output, it was not maintainable, and I could not figure out what YAML to write anymore or debug it, right? So it turns out there's a whole different way of thinking about this, which is through a separate program called Node-RED, and that lets you define rules literally like this. It's a kind of like visual programming language, and this I feel like is much more easy to read because you can look at this and you can say you make these labels and then you tell it what these little nodes do. And then you can now look at this and be like, okay, well, clearly when there's bathroom motion, then turn on the lights and then wait 5 minutes and then turn them red. Which means if I want to debug this, I have a much easier time of going in and like tapping into the outputs and figuring out what's going on. And then as soon as we're going to see, this starts becoming way more useful when you start doing more complicated rules and chaining conditions and things. So this is Node-RED. It's a totally separate piece of software. You can run it on the same machine as Home Assistant, or you can run it on a different one because they talk over a protocol to each other. So this is how I like to now think about the system, where Home Assistant is all about talking to devices. It's the one that knows how to interface with the particulars of each device I've got in the house. And it's also doing the state management. So it knows when it goes, it's monitoring devices and it's aware of when it's told a device to turn on or off. So that's where the sort of like current state snapshot lives and how it goes and talks to all the devices. Node-RED is a rules engine. It's a visual programming language and it's a rules engine. It does not have any state itself. It does not know how to talk to any devices itself. All it can do is tell Home Assistant to go talk to a device. So having this separation started making a lot more sense in my head. And I was able to then go and do create a lot of these rules in Node-RED, which was a way faster, way easier way to do this. So let's start looking at some of the actual devices I use and talking about these inputs and outputs. My favorite lights are the Philips Hue lights. I've been using these for, I think I've got the same bulbs I bought like 7 or 8 years ago, which is, in my opinion, it's a long time for the Internet of Things stuff. And it's amazing that they are still relevant and still work great. So the reason I like these is because the bulbs themselves talk Zigbee, which is a protocol for doing this sort of device control. They talk directly to Philips Hue's own hub, and this little hub is a device that actually has an HTTP server on it, which means I now have a completely locally controlled system to deal with the lights. No internet required for this to work. Some of the new bulbs actually have Bluetooth as well, which means your phone can talk directly to the bulbs. They say they only support about 10 devices in that mode, so I like to use the hub instead. So once you've got this, then you can tell that hub to go and control the lights, which also means it's really fast because it can go and like simultaneously tell all the lights to do something at the same time, which is great. And then if you don't need an internet connection for this to work, there's no subscription service, it's all local in the house. And then this gets connected into Home Assistant. For temperature, I've tried a couple of different things. There's like very good Zigbee Z-Wave devices. They tend to be more on the expensive side for various reasons, mostly licensing reasons. And those are fine, but if you want to do like, I don't know, throw 10 sensors around, 10 times $60, it turns out is a lot of money. And I would rather spend 10 times $10 instead. So there's a different kind of sensor. It's this. It's called the standard is 433 megahertz. It's an unlicensed radio spectrum, and the it's like a really simple protocol. And these little things basically just chirp every couple of seconds. There's no pairing. There's no authentication. It does mean that like any of your neighbors can monitor these sensors just as well as you can. And they look anything, this is like the one that I use, it has a little screen on it. You can get ones without a screen. There's tons of different sensors. You connect this into like a radio receiver that you can connect into Home Assistant, and then that radio receiver receives any 433 signal that's coming by. And I live on a busy street, and it turns out that that frequency is also used by pressure sensors in car tires. So all day long, I'm just getting pressure readings from cars driving by the street, which is pretty funny. It means I can't use the auto discover feature for devices that Home Assistant has, because it would be full of cars, which is not helpful. So yeah, these things have been great. They're reliable because they're so simple, and they're also extremely cheap, which is great. So if you want to know when someone is at home, there's several different ways you can do this. And so one way is to install an app on your phone, which it can use the phone's own location APIs, and the phone is then aware of where it is, and they can report that back into the system. That works pretty well. That's actually the one I use. There's also a way you can do it where you can install something in your house that can talk to your Wi-Fi router and ask your Wi-Fi router what devices are on the network, and that way it doesn't require any app on the phone, which is good. Couple downsides of that, it's your phone isn't actually always on Wi-Fi, even if you're at home, especially because the phones are trying to do power management, so they sometimes turn off their Wi-Fi radios, so it's not 100% reliable. You can also do it with Bluetooth beacons, so you can have either direction, like you can have a Bluetooth device at home listening for your phone, or your phone can be listening for a beacon and report that. You can also actually combine multiple of these different options into a single person record in Home Assistant, which is cool. So you can actually track using multiple ways. So there's two apps that are sort of recommended out of the box for this: OwnTracks and GPS Logger. I think GPS Logger is only Android. OwnTracks is on both iOS and Android. Or yeah, the Wi-Fi router can push into Home Assistant or watch for Bluetooth devices. So this is a pretty good way to sort of be aware of who's at home, and then you can have that as one of the inputs into these various rules. So you're going to want to configure a sensor for the sunrise and sunset times, which really just needs to know where the location of your house is so that it can compute the right times, and it's just math after that. So it's a really simple one, and this is built into to Home Assistant and Node-RED. You're going to want to configure a rule for calculating the sun angle in your windows. This one is really cool, and so I know that I have a window at this, facing this direction, which means at when the sun's angle is a certain amount, that means there will be sun in the window. But that angle changes the time of day that is throughout the course of the year based on the seasons. And I live in Portland, Oregon, which is pretty far north compared to most of the U.S. So it actually, sunrise varies quite a lot, between 4:30 and 9:30 p.m., which is a lot different than if you're in the Bay Area, where the difference is only a couple hours. So it becomes really important to get that one in there. You're going to want to find some sort of input to get weather data. So weather forecasts both hourly, so that you can do the really short-term triggers, but also daily weather, so you can know if it's going to rain the next day. For this one, I like darksky.net. They have a free tier that works pretty much. You'll say under the free tier if you're just using it as for the one machine you've installed it on. Then you're going to need some outputs. So let's talk about window shades. This one is there's two different kind of ways they work. You can buy a motorized shade, and it's usually like the roller ones, where it's all self-contained in that, and then it's got a little motor and it spins and the shade drops down. There's also an option of retrofitting existing shades that you might have. And I live in an apartment, and I didn't want to install new shades, so I'm using this one, which you attach it to the bottom of the loop of the chain, and then it can pull the chain in both directions. And this one talks over Bluetooth. This one actually hasn't been super reliable for me, and I don't know if it's because I installed it wrong or something, so I'm reconsidering whether this is the right option, and I might just go and get the roller shades and put them over my apartment shades. We'll see how that pans out. But once you've got all of these things hooked up, now you can actually start making some rules. So let's take a look at one of the Node-RED rules for this. So this is a timer at the top. Every 5 minutes, check if the sun is up. Check the cloud cover to see if it's cloudy, because if it's cloudy, there's not going to be any sun in the window. If there's no cloud cover, or less than half, then check, is the sun shining in this window right now? And if so, drop the shades. And then I haven't bought the shades for the second window, so I haven't wired that one up yet. But this is actually now pretty readable, and you can kind of see what it's doing as you're looking at this, as opposed to writing a YAML file or writing any code. Then you can do something like this. So this is a trigger which will run on sunrise or sunset. So when the sunrise, when it crosses sunrise, then it'll check, is somebody at home? And only if somebody's at home, it'll then open the shades. So that's one of the outputs, is the shade control. I also have, I have an air conditioner, and this is another challenge of living in an apartment. It's not built into the apartment, and it's like a floor standing unit, which means I can't use a Nest, even if I wanted to, which I don't, but I can't even use one of those Nest things, because those require wiring up to a physical one, and it's built into the house. My air conditioner is a floor unit, which is controlled via an infrared remote, which is, I thought was going to be impossible to integrate with this. And then I found this little device, which is a infrared transmitter that connects to Wi-Fi. So this thing, you can actually tell it, you can have it learn a sequence of, like, you shine a remote at it, it learns it, and then you can tell it to go repeat that back. So I can have it learn my IR remote, and then it'll go broadcast that back out to the AC and tell it what to do. This is probably the sketchiest device I have on my network. When I was reading up on this, one of the tips everybody was saying to do is block its internet access, because apparently it does go out and talk to something for some reason. But I just firewalled that off at my home network, so it's only local. But yeah, if you are going to get this one, definitely do block its internet access. So now with that output, we can wire up some new rules. We can say, using the weather, if the forecast in the next hour is going to be over some temperature, then, and if the AC is currently off, turn on the AC. Or if it drops then below a threshold, then turn the AC back off. Or if the TV is turned on, we don't want the noise of the AC to overpower the TV if it's not that hot out. So only if it's not super hot out, then turn off the AC when the TV comes on, which is pretty cool. Speaking of the TV, this is another one that I wanted to add, both as an input and an output, although I think it's actually more useful as an input, to be able to tell the state of your TV. I'm pretty unhappy with the current state of televisions right now. Smart TVs are complete crap. They are like, don't put a computer into my TV. I want to put a computer next to my TV. Like, let me buy an Apple TV and put that, and connect that to the TV. I don't want my TV to have an operating system. Because there was like the Samsung thing where it turns out the microphones were on and it was like transmitting audio, which is like, why is my TV doing that? So it's almost impossible to buy a TV now that is not smart. Basically the only way to do it is either get a computer monitor that's big enough, but those don't usually come in like 50-inch sizes. But if you look for a commercial display, you can usually find one. And commercial display or like digital signage, if you look at all the stuff that's out here, those are not smart TVs, those are digital signage displays. And they're sold to a different market because they, in this setting, you don't want it to have an operating system. You want it to be just on, and that's all it's going to do. It's going to be piping in some video. One of the features of commercial displays is that you also probably want to be able to control them from a central place, to be able to change the channel on all of them all at the same time or turn them off at the end of the day. The one I have has a serial port on the side. So I have a USB to serial port cable, which means now from my computer, from the controller, I can send the TV commands, or I can read the status. And someone thankfully did all this work for me, because they read the manual, which comes with it, which tells you the list of serial commands, and turned it into a Python program. So now you can just run this, and they actually turn it into an API, so it's even easier to use. So that's been pretty cool, because now I can just pull the TV status and say, hey, is this on, and then wait for it to turn on, and then do some rules after that. This has been, I think, the most fun one. This is something that I did build from scratch, more well, kind of. I wanted to know, is somebody in the bed? And there's not really an off-the-shelf product for that. So what I ended up doing was finding this flex sensor. So that little rectangle on the right there is very small, and basically it changes its resistance depending on how much it's distorted. And then that is just an amplifier circuit to turn it into a voltage between 0 and 5 volts. So I was like, okay, this seems like something I can do. I don't have to build this circuit, thankfully. I can just buy this piece. It's already soldered together. So I just hot glued it to the bottom of the bed. This picture's upside down because I'm not going to install this upside down. So this ends up getting flipped, right? So then as the mattress slat, as you sit on the bed, then the slat bends, and then this thing changes its resistance. So then the challenge was, how do I get that into Home Assistant? Well, thankfully, again, there is this amazing community that has built this other platform called ESP Home. So if you're familiar with the ESP32 or ESP8266 chip, it's this really small, inexpensive, like $3 chip that has Wi-Fi and Bluetooth in it and a little microprocessor. You can load it into an Arduino environment and write code on it. You can buy it as the standalone chip, or you can buy these little kits that come with the breakout pins and a USB so you can actually program it. And then ESP Home is a layer on top of that where basically it's a sort of like a code generator where you don't write any code and then you just tell it what to do and it writes code for you. And again, there's this massive community of people who have built integrations for all these little components. So you can go to their website and you can find, okay, I have this sensor that does X. I need to connect it into ESP Home. And then you just download that and read the instructions and do what they tell you. So this is the code for mine, which is just, again, a YAML file. And it says, okay, this is an analog digital converter platform, which means we're going to take an analog signal and convert it into a digital number. We're reading from pin A0. We're going to call this the right side of the bed. And then there's these filters, which I experimented with a lot to find some numbers that worked just by watching what was happening. But basically, it's taking a reading every 100 milliseconds and then averaging the 30 readings. And then every either 2 minutes, or if the value changes by more than 0.3, which I just magic number I found after a while, it'll report over Wi-Fi to the controller. So, and I have one for each side of the bed. So then I just run a really long wire into this is the ESP device in my little box, which sits elsewhere, and then I've got these long wires that run into the sensors under the slats, and then it's wireless out to the controller. And this is what it looks like in Home Assistant. You can see that the voltage then drops when someone gets into the bed. And then you can write a rule in Home Assistant to turn that into sort of bed presence of is somebody in the bed or which side is occupied. So then you can start using it to make rules. Like if one person is at home and one person gets in bed, turn off all the lights. And then if one person's at home, one person gets out of bed, is it dark outside? Because we know the location and we know the time of day. Then if it's dark outside, then turn the lights dim red, but if it's bright out, turn the lights all the way on. But if there's two people at home and only one person gets in bed, turn only the bedroom lights off. And as soon as both people get in bed, turn off all the lights. Or if one person gets out of bed, then turn the lights on just dim red, because then you can at least see a little bit around the house, but you're not going to wake everybody up. But if both people get out of bed, turn all the lights on. And it turns out that this was a nightmare to try to figure out in the YAML configuration of Home Assistant, but in Node-RED, it's actually pretty reasonable. It kind of looks like the flowchart in the slides, right? Where it's when there's from 0 to 1 person in the bed and 2 people are at home, then do this thing. So this has been this is probably the thing that's worked most reliably out of everything I've tried at home so far, which has been pretty fun. So the last thing that I'm in the middle of working on, it's not done yet, is an automatic cat feeder. And this one, again, has been pretty fun. There are plenty of off-the-shelf automatic cat feeders, but those are like firmly in the camp of it relies on that company's API to be up and running to tell the thing when to dispense food, which just makes no sense to me. At least just like push that timer data into the device and let it run locally, but here we are. So what I've done is piece this together from a bunch of parts. I'm, again, trying to write as little code as possible. I'm also not a hardware person, so I'm like, I'm terrible with, I can't do any machining for sure, but also like even just screws are about the most I can do. So I got a kitchen scale. This was like, $4 kitchen scale or something. And if you rip it apart, this one has this nice little disc. And then that bar underneath the disc is like how the scale works. That's, again, a flex sensor. So as it gets slightly distorted, then it can measure that. So I was able to screw it into this piece of wood that I got to sort of turn it into this little platform. And then I made this, I didn't even cut this wood. I bought the wood cut, because you can do that. It's like, internet's magic. And I spray painted it black. So I turned it into this little like stand, put the scale at the bottom, got this cereal dispenser, bolted it to the piece of wood, and then got a giant motor to turn the crank of the cereal dispenser. And then that thing is the lid for the top, and that is a ultrasonic sensor, so it can measure distance. That way I can know how much food is left in the chute. So this is what it looks like right now. It's waiting. Oh, and I got a button in there too for manual control, always important. This is what it looks like right now. It's waiting for me to finish wiring it and writing the software for it. So that's my project when I get back from here. So future experiments, things I'm going to work on in the coming future. I'm pretty happy with the way things have been going right now. I got a few kinks to work out, like the shades aren't quite working right, but overall I'm been pretty happy with the platform here. I want to add a pressure sensor under the couch to be able to tell if somebody's sitting on the couch. The way that the couch works is there's like little peg legs, so it's kind of hard to get sensors in the right spot without it sliding around. So got to figure out something for that. I think I want to add an audio level sensor to be able to just measure sort of ambient noise in the house. I figured that'd be a fun input to try to do something with. I want to find a way to do voice assistant voice control, but without going out to the cloud again. There is this platform called Mycroft.ai. I have not had time to play with it yet. And again, they have a pretty good package where you can install it on a Raspberry Pi, so that's, I think, going to be my first way I try that out. I also want to know where my cat is, whether she is like in her basket or sleeping or like in the litter box. So I'm going to try to find some way to combine maybe NFC tags or Bluetooth tags. I haven't figured that one out yet, but I think that would be a pretty fun one too. So I hope you got something out of this. I hope you have some ideas about what to do with your own setups. These slides are all available. Feel free to download them, and you can follow the links that way. And thank you all for coming.